All right, guys, this is what to do today. I'm going to give you some help and some hints on some of these just to make sure you're on the right track. Um, Number one here is just triangle sum. So you just add and subtract from 180. I'm not really going to talk about number one right here because I think that's straightforward. But on number two, you have to recognize that this is an exterior angle and the non-adjacent are over here, the remote interior. And so you have to use that relationship. The exterior angle equals the sum of the remote interior. So your angle one is just adding these two angles up, okay? Now on number three, since this is the exterior angle, it would be the sum of these two. And since you're missing this angle, then all you would have to do, you can do it two ways. You can write it as an equation. Let me get my pen, which says 152 equals 115, oops, sorry, plus the missing angle. We can label that as x. Or you can find angle 1 by doing the opposite, which is 152 minus the 115. Okay. Now you're going to get into some problem solving on on number 4 here. You need to use these vertical angles. So that would give you angle 2. There's no math to that. But now you can get into angle 1 by using your angle sum. Remember, every triangle has the sum of 180. And we're just, since I know this is going to end up being 42 as well, I can find angle 1 by doing 180 minus that sum of 50 plus 42. And I could do that also to find angle 3. Okay. Now, for a problem like on number 5 here, you have to use this linear pair. I'm already showing this. I meant to put an effect on that. So let's do that now. So it's going to fade in. So you start with finding angle 1, which means I'm doing 180 minus that 118. So that gives me my angle 1, which is 62. All right. And now that I have that value of that angle, I can get to angle 2 using this triangle right there. Now, angle 3 can vary. So I can, if I want to use the exterior angle theorem, then I have to look at the whole triangle, like putting the two together. And that would indicate that 3 and 49, or I'm sorry, not 3 and 49, 3 and angle 2, like those together, plus the 49 would equal the 118 on the outside. If I'm not using the exterior angle theorem, then I would want to focus on this sliver of a triangle right here. And then I would have to use another linear pair with that 73 to get that interior angle, which is 107. And then I can find angle 3. Okay. Now for a problem like number 6, you need to recognize you have parallel lines here. There's that arrow, which means that I'm going to have alternate interior angles, congruent and same side interior 180. Now hopefully you see alternate interior with the 47 and 3. So those would be congruent using that transversal. Or you can see alternate interior with angle 2 and 52. So those would be congruent. For angle 4, this is when we're using same side interior. Change my font real quick. There's same side interior with angle 4, which means I'm doing 180 minus the 47. Okay. So it's going to take, some problem sums. There's not just one way. You can do same side interior as well with angle 1, and then you have your triangle to get to angle 5. So now I've highlighted two triangles here for 7 to see that they overlap. There's actually 3. There's my blue triangle, there's my yellow, and then there's this triangle in the middle here with angles 5, 6, and 3. To start this, you want to use that there is, it's not showing, a linear pair right here. I want to find angle 5 first, and that is just by doing 180 minus that 144. So that would give you my angle 5 is 36. Okay, I'm going to draw an arrow pointing to that is 36. And then from there, I could do the yellow triangle here. Angle 5, 36, the 38, plus angle 7, those three would make 180. Okay, and then I can use my vertical angles to find angle 3, and then I can get to the smaller triangle with 5, 3, and 6. So you're going to do some problem solving. Once you get to the 6, you get to angle 1 using the blue triangle, which is the 90 angle right here. And then there's angle 6 and angle 1, and then you can do linear pairs. So it's just kind of what we've been doing some problem solving. Try your best on this. Ask questions in class while you're working on it. Then from this point on, you have to do algebraic reasoning with those two angle theorems in your flip book. So this first one, hopefully you recognize, is just triangle sum. So you're just basically adding every triangle equals 180. So we're either using the sum of 180, or you're going to use the exterior angle if it's showing equals the sum of the remote interior. Okay, so the 8 and 9 is triangle sum theorem. So we're just really, I thought I wrote this down by then. We're just adding up the three angles. So we're doing the 10x minus 11 plus the 3x minus 2 plus the 3x plus 1 equals 180. Okay. And then now we're just combining the like terms for our variables and then our constants. Okay. And then solving for x. So here they just want you to find the value of x. There's no plugging in needed here. 10 is dealing with remote interior. So the 151 is the exterior angle. Okay. And the 11x minus 1 and the 20x minus 3 is the remote interior. So your setup hopefully is 151 equals the 11x minus 1 plus the 20x minus 3. Okay. Now, when you get to the back, okay, this correlates with our more practice that we did in class. So like number 12 is similar to, I think it was number 5 on the more practice, where you have to find the x first. All right, so understand these are vertical, and now this expression, this 6x minus 11 is in this triangle. So first find your x, okay, using the triangle sum. Find it, plug it in, and then you can find your y. Now what I want to talk about is the remaining, especially 14, 15, and 16. 14, they're just telling you the name of the triangle, M and P. They're telling you the expression for each angle. Find x and then plug it in. So basically we're just, I thought I had it in here, but maybe it's not. Basically we're just adding up angle M plus angle N plus angle P equals 180. And then you can just substitute the parts and solve for x. So this one's not that as difficult. It's number 14 where you have to recognize some key information. So here, right here, it says R is 5 more than twice x, where S is 1 more than x, and T is 16 less than 7 times x. Okay, so might want to draw a picture of the triangle RST, okay? And then I'm starting with angle R, 5 more than twice x. So in this angle, twice x would be 2x, 5 more than that would be plus 5. For angle S, which is 1 more than x, that would just be x plus 1. And then since T is 16 less than 7 times x, That is 7x minus 16. Less than is subtraction. And then from there, we're just writing the equation equal to 180. Solve for x, and then plug it back in to find each angle. See, on this side, you have to plug back in. Where in the front and on number 12, you're just finding the variable x and y. So on 15 here, the difference is in the first one, they tell us the variable x. Here, they're saying angle A is 13 less than C, and angle B here is 11 less than 4 times C. So your unknown, I don't know if y'all see this, is really this angle C. Angle C is going to be my x. So if I was thinking about the equation or the diagram, C would be x. To show A is 13 less than that would be x minus 3, and B would be 4x minus 11. And then you're back to writing the equation equal to 180, and then plugging back in, because they just want you to find each variable, each angle here, sorry. Now, same kind of scenario on 16. K is 9 more than J, and L is 21 less than J. So I was hoping you would recognize that it's showing your angle J is your unknown, is your variable. So that's your, oops, sorry, that should be your x. And so if I just start off with J is your x, okay, angle J equals your x, then that means K, which is 9 more than J, would be x plus 9. And then you can do your angle L. See if you can figure that one out. And same scenario, write your equation equal to 180, solve for x, then plug back in. All right, so this is just going to be some helpful hints that you can use, and then you're turning this in before you leave today. All right, thanks.